Hi everyone, so I'm back with another video of mine which is gonna be an OSI model, and as we move forward we will also discuss about various layers of OSI model in detail. So first things first, let's start with OSI model. OSI model, which stands for Open Systems Interconnection. The whole meaning is declared in these three words clearly. So this was introduced by ISO International Organization for Standardization in 1984. So the main reason and the history behind this is that in 1970 and the following years, what was happening that, for example, we take the example of Mac here, and the thing was that there was an increase in the number of networking devices, computer devices, networking applications, computer applications, who were using network services, and as the number in increase of them, vendors were having a little issue here, and also the end users. So what was happening was that, for example, we have Mac, and Mac is going to communicate with another Mac device over the same network, or maybe in a different network. So the thing was that they were using proprietary protocols in order to make the communication possible between each other. For example, Mac to Mac, or maybe IBM computers to IBM computers, Sun Microsystems, Microsoft, and other examples as well. But the main issue was to make communication possible between each type of device, irrespective of their vendors. And this was important because every organization cannot just afford to go and get a Mac system for their whole organization, or maybe some other reasons as well, where there was mandatory that they can be able to communicate each type of devices with each other. So moving forward, what was happening that if Mac wants to communicate with Solaris systems, or maybe Solaris wants to communicate with IBM systems, or IBM to Mac, they cannot use their proprietary protocols to make communication possible with different vendors. Why? Because proprietary protocols are mean for those machines only. They have no knowledge about how IBM works, unless and until Mac is creating IBM machines also. But that was a different scenario. So the only thing that can be possible here and that can resolve this issue was to have some open standards, and as the definition is open standards interconnection, OSI model. So what was here that ISO introduced a basic model using which every company have to follow if they wanted to make their devices communicable with the devices of other vendors. So if Mac have to make the communication possible with IBM, they will have to follow this basic protocol, these open standards, whenever they are creating their own application or maybe their own machine. For example, Mac here. And if Mac wants to communicate with Solaris, Mac as well as Solaris will have to follow that standard. And that was OSI model, the basic model which was introduced so that every vendor out there can follow that basic model to create their application as well as to manufacture their hardware, and that can lead to the communication between each type of devices all over the world. So moving forward, if Cisco here will have to create their application, will have to create their hardware, that is router here, they will have to follow the protocols standardized for network layer, because routers, as you know, works at layer 3, and that is why they will have to follow all the layer 3 protocols, or maybe the standards. They can enhance them in the future, but they will have to the basic model to make their hardware communicable with any device out there. So OSI model is just a reference model which defines and standardizes the way communication takes place between two network devices, and to make communication possible between these devices, irrespective of their vendor, of the hardware or software. So the communication process is also divided into various layers so that it is easy to define what is happening at each layer, and to make someone understand the basic process of communication. So this was also used to teach how the networking was really taking place out there with the use of those protocols. And as we see, there are a lot of number of protocols defined at each layer. So if we take the example of application layer, we can have DNS, HTTP, HTTP, HTTPS. As the presentation layer, we can see some encryption, decryption, compression, decompression, or various things also. And session layer, we can see the sessions we have created when we are accessing a particular website, or when even when we are on a TCP connection, or maybe we are on a telnet. It's creating a session for the time period and some other various aspects also. And as we see, transport layer, network layer, data link layer, and physical layer as well. So the next concept here is that encapsulation. As we go down from application layer to physical layer, application layer is on 7th, then 6, 5, 4, 3, 2, 1 at physical layer. So as we move down, the whole process is encapsulating the data. So at the first three layers, we have data. It is in the form of raw data, and after that we can move downwards, and then we have segment. The transport layer divides the whole data into segments so that there can be a reliable communication. We will discuss this in detail in future videos, but for now this is all we have to know. And after that, the segments are further added with headers and some other things, and it is known as packet at the network layer. And then we have frames at the data link layer, and then the data link layer forwards it to the physical layer, in which we have the data in the form of zeros and ones, the binary you can say also. So that because the medium used at physical layer, for example LAN cable, access points, they those mediums cannot understand anything but only the zeros and ones. So we have physical layer also. And after that, when we move upward from physical layer to application layer, the whole process is decapsulating the data, and bits to frame, then packet to segment, then data. As we move forward, we have these 7 layers divided to two categories. The upper four are for host to host, and the lower three layers are point to point. And why they are known as this? Because host to host means that the upper four layers, these 4 layers, will only be applicable and takes place at the host side. Means maybe the sender and the receiver. It can be a Windows machine also. It can be a Mac server here. It can be a Windows machine or Windows client machine, both. So the host to host protocols are only taking place at the host side. And we have then point to point. And why these are known as point to point? Because they are not taking place at the host side and just working at the intermediate nodes. They are only applicable at the intermediate nodes, which can include LAN cables, access points, bridges, switches, hubs, routers, all those intermediate nodes. They are known as point to point. So this was all brief about OSI model. And moving forward, we have one more thing here, TCP/IP model. And this is the most popular model as well in the way of conceptual, because this model is really used in real world. That OSI model was just a base model, and on the basis of that there were other models also developed. And one of the famous models out of them was TCP/IP model, which is used in real world. It was formerly known as DoD model, and in 1982 it was set as a standard for military computer networking. This was known as DoD model because it was funded by United States Department of Defense. So why it was popular? Because it does not really require a specific hardware or software environment. The only requirement was that the sender and the receiver, or the hardware or the software, should be able to send or receive packets on a computer network. And that is the reason this was applied basically on every computing platform. And moving forward, the reason why it got its name TCP/IP, because the ones who invented it were of a belief that only two protocols are the most important for communication in the networking world, and those were TCP, Transmission Control Protocol, and IP, Internet Protocol. Because TCP was the one who was able to make the communication reliable, and IP was the one using datagrams. It was able to make the communication fast. and we will discuss this more about the datagrams and other things as well in the later videos, but for now that's all. This is the basic difference we have between them. So TCP/IP model, as you can see, is more practical approach, and OSI model is here more theoretical approach. And the inventors really just combined some layers and merged it as one here. So the upper three application, presentation, and session layer are combined here as represented as application layer. And after that we have transport layer, which is represented as transport layer. And after that we have network layer, which was represented as internet layer, because the inventors of TCP/IP model were the actual one who created internet, who started internet, so they named it as internet layer. And after that they merged data link layer and physical layer to the network access layer. But many authors really argue on this, that those two layers should be different, but it's what TCP/IP model inventors really believed in, so they named it as network access layer. So that is all for TCP/IP model as well. And as we got to know what is the main reason to create or introduce OSI model in that time period. Now this is all for this video, and if you have any more questions about this, about more things to tell me or ask me, you can ask me in the comment section. And thank you for watching this video. We will discuss more about these layers in the upcoming videos. Thanks for watching. Bye bye. Have a nice day.